Hello everyone. Today we will be doing LeetCode problem 54, which is spiral matrix. This problem states, given an m times n matrix, return all elements of the matrix in spiral order. Example 1. We have three matrices, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're just going to spiral across the top, down to the right, to the left on the bottom, and then around until we hit the last number. Second example, very similar. Three matrices, and just keep spiraling until you hit the last number. So the way we're going to do this is we're going to traverse through the top first. We have four variables, four integers, top, bottom, left, right. We're going to go through the top row, and then we're going to decrease top by 1, so then we're down to this row, and then we're going to do the right, decrease right, then do the bottom, decrease that, and so on and so forth until we hit all the numbers. So the first thing we want to do is we need to return a list of integers. So we'll just do that. And then we'll do the standard if the matrix is null or the matrix length equals 0. And just return a result. Don't need the extra parenthesis there. Alright, now we're going to define those four variables. Int left is going to start at 0. Int right is going to be the first matrix. That length minus 1 for the 0-based indexing. Int top is also going to be 0. And int bottom is the entire matrix length, lngth, minus 1. So we're going to put everything inside a while loop. So while left is less than or equal to the right, and the top is less than or equal to the bottom. Alright, the first thing we need to do is go through that top row. So for int I equals the left, which starts at 0, I is going to be less than or equal to the right, I plus plus. So this will go from left to right along the top row. So we're going to take our result, which is what we're going to return. We'll add matrix top I. Okay, so first pass through over here on the left. Left is 0, top is 0, so we're going to grab the number 1. Then we're going to increment I and grab the number 2. Increment I and grab the number 3, and that is when left will be equal to right, and so then we'll break out of this for loop. Then we need to increment, after we get done with that first row, we need to increment the top, so then it will go down to the second row. Alright, so now we need to do the right side. So for int I equals top, I is less than or equal to the bottom, I plus plus. So basically the same code, only we're going top to bottom instead of left to right. So this time we're going to add matrix I, and now we're going to add the right side. And then, as you can probably guess, we've got to decrease the right side so we don't duplicate that again. Alright, halfway there. So now we're going to do the bottom. So if top is less than or equal to bottom, so the first thing we're going to do is do a for loop here for int I equals the right side. I is greater than or equal to the left side. And I minus minus. Oops, not minus minus. So now we're going to add result, add matrix bottom, and sub I. And then we need to decrease the bottom. And that will be it for the bottom. So now we just need to do the same thing for the left side that we did for the bottom. So if left is less than or equal to the right, so we're going to do a for loop for int I, probably be easier to copy and paste the previous code, I equals bottom, I is greater than or equal to the top, I minus minus. So now we're going to add the left side, I matrix I left. If I could type. And then we need to increase the left. So shift that over. And that should do it. The last thing we need to do is return the result. And there you have it. So let's run that and see what I messed up. Oh, nothing. Accepted. Case 1, case 2. Okay, we'll submit that. Beats 100% of users with Java. Fantastic. Let's debug this real quick. Okay, so the matrix we're going to use is the first example, the 1, 2, 3, 4, 5, 6, 7, 8, 9 that you see on the left. We're just going to step into that. It is not null, and the length is not 0, so we're going to skip right over that. So the left value is going to be 0, the right value is going to be 2, top is going to be 0, and bottom is going to be 2. So we'll enter the while loop here. For I equals left, I is less than right. So we're going to add the first number, which will be the 1. So you can see over here on the left, the result is 1. And we'll do it again for the 2. And finally for the 3. And now we need to increase the top. So we move down to the second row. Okay, so now we're going to do the right side. We add the matrix, which will add the 6, because we grab the right value of the second matrix. And then we'll add the 9. And then we'll decrease the value of right. Top is less than bottom. 1 is less than 2. So now we need to traverse across the bottom. This will add the 8, and then it should add the 7, which it does, and then decrease the value of bottom. So while left is less than or equal to right, we're going to add the 4, and finally the 5. Whoops. Sorry, add the 4, increment left. And we'll go through this again. And the top is now the second row, and so it'll add that 5 finally at the end there. Increment the value of top. It should just skip through all, because we've gone through all the numbers, so it should be, and while left is less than or equal to right, which it isn't, left is now 1 and right is 0. So we'll skip out of that and return the result. So the time complexity for this is O(n) squared. We have a while loop, and inside there we'd have 4 statements, another loop. And the space complexity is just O of n. The only way the space will increase is if we increase the number of matrices. And that's it. So thank you once again for watching, and we'll see you next time.